Hello. In this video, we're going to look at making a destructible. So we're going to make a destructible crate. This is what I have for my effort. It's a rigid body, so the tank can move it. And when it's shot, it can explode into 8 pieces. So we'll be looking at how that was made in Blender, using Blender and GIMP, and then we'll look at how it's assembled in Godot into something that works. So let's disappear one of these corners so we can see it a little bit. It's a little bit hard to see. It's visually distracting in this way. What we're aiming to do is to make a crate that has some body, so when it comes apart it doesn't give that paper thin appearance. And I'm not entirely satisfied with this model, so we'll be looking to sort of address some of the issues with this and maybe make myself a slightly better crate. First off, we'll look at how it's made with Blender and GIMP. So first thing we're going to need is a UV image. So Control New in GIMP to start a new image file. I made mine 128 by 128. It doesn't need to be a huge image or anything. We can select a wood grain pattern. Fill with pattern. Let's change tools. In colors, I would reduce the saturation because that pattern is way too saturated for what we want from it. And something that looks a little more water washed would make more sense. So we'll select a paintbrush. In the GIMP default brushes, there's this set of horizontal lines. If we change the aspect ratio, I have it at 14, it squashes the brush along the vertical so that it's not square. It has a different aspect ratio. I have the force set to 61 and I'm just using a black color. So I'm gonna try to pick where I start at the top of the image, considering that I want to copy a section of the image to paste around and make a frame for the crate. So I'll start in just giving a brush stroke, and what I'm drawing here is the slats. So that's more or less the slats, and we'll firm that one up a little bit more. So that's the wooden slats for the crate. I'll get the box select tool and I'll go into the view dialog and enable snap to canvas edges. We'll zoom in a little bit more. And let's see what's the most favorable slat here. Something like this one would work pretty good, I think. So I'll select this section to copy as the frame edge to the crate. So I'll copy that, I'll paste it. I'm going to change its color. So I want it to be darker and stand out from the rest. So I'll just crank down its brightness a bunch. M to get the move tool, and I'll move this up to the top because it has the darkest line. I want the darkest line on the inside. Then I'll copy that again because the copy that is on the clipboard right now doesn't have the darkened color. So we'll copy, paste, shift rotate by 180 degrees to get that dark line on the section I want it. M for the move tool, and I'll paste that at the bottom. Control V to get a new layer copy of it. Shift R to rotate it. I'll rotate that by 90 degrees because the black of where the black edge lands I'll change to the move tool and put it onto the appropriate edge. I'm going to copy that again in the new orientation and paste it. Shift R to rotate it. Shift R to rotate it. Actually, I accidentally pressed T. I'll rotate that 180. M for the move tool. And anchor that layer. So we'll anchor the layer. All of the edges look good. So one last time I can get that rotate tool. So Shift R. And I'll rotate the whole image by 90 and get it standing up the way that a crate should be standing up. So we'll call that the UV image. We'll export that to the desktop. I'm just overwriting a file with the name crate UV. The image on the desktop is only temporary, but this image does end up in Godot, so giving it a specific name is for the best. So starting off with the default scene in Blender, we'll get rid of the light in the cube. We'll take the cube into UV editing. In the UV dialog, select cube projection, and that will unwrap the cube in the way that we need it unwrapped. We'll get that UV image onto there, and we'll put it in as the base color for the texture. So we'll change that to image texture, select crate UV, and go into modeling. So that's what we got. It looks okay. And from here, we will go into Inset Faces tool and select individual. So on the Inset Faces tool, we're just going to pull this and inset a face that intersects with that one black line around the edge. And that should work good, just like that. So with that done, we can just click off the image to deselect. We'll knife cut the cube into 8 pieces. So what we're looking for is, I try to land the vertices in the middle of each side. And we'll go from top to bottom, making a knife cut, one knife cut down and up each of the sides, meeting up in the middle of the top and the bottom. And that will get the cube into 4 pieces. And then we'll do another cut to put it into 8 pieces. So more or less like this. The knife cut tool x-rays its cut through the piece, and that can be a little bit visually distracting, but just kind of rotate the cube around a bit, and you can usually find a way to be able to see it without too much disruption from that x-ray, and see where the edges are at and stuff. So that's 2 sides. The tool will snap to edges, and you want to try to hit those edges, because when you miss them, it will create a need to repair something. Will create a awkward face that's not going to work out so great. That's 3 sides. The pattern might not naturally occur the first time you cut it, but a couple of practice cuts and you're an expert. It's not that difficult. So that's the cube into 4 pieces. Now we'll just do one around the sides, and I'll start at the one middle vertices in one of the faces. And I don't have any special pattern, I'm just kind of doing random zigzags. I didn't intend to do that, but we'll just settle for it if we can. I'm actually using two mice here because I have a mouse with a bad button and a mouse with a bad scroll wheel. And I live in a small town where it's actually quite difficult to buy a mouse. I can find a field mouse, but not one for my computer. Okay, so that's cut into 8 pieces and it can be separated at this point. So we'll go into faces. To separate this, I'll expand the dialog for collections, and I'm going to rename cube to cube 001. So cube period 001, and that's the standard naming convention in Blender. So when I'm done separating the 8 pieces, it will be cube 1 through 8. So to separate them is pretty easy. C to get the circle brush, you grow the circle brush a bit, and one click, P separate selection. So C, click, P, enter. It really can go pretty fast doing it that way. The separating the pieces like this at this point is actually the trick to avoid any modeling of edges that we don't want to have to model and deal with individually, or it makes it the most easiest way that I could find to make a cube with some thickness and substance to it with a minimum of modeling. This one sharp, this is a little bit awkward. It's not going to come across that great. So we'll tab into object mode, deselect, and select everything. Make sure that everything's selected. Then tab back into edit mode. I'm going to turn on X-ray and wireframe so that we can see what's going on here and why to separate the pieces like this. So we'll select all, extrude, scale. And this is one of the parts I want to correct on my model is I don't think I gave my model enough thickness, so the one in Godot. This thickness I figure would come across better in Godot if I had exaggerated it more. So I'll shrink it down even a little bit further to make sure I'm exaggerating things. And we can see inside there with the X-ray all of the faces that represent the thickness that we just created. So by separating the pieces is what creates these edges and saves having to model them. So this is the last part. I want to extrude the frame as well, and I've never found a perfect way to do this. Yeah, once the pieces are separated, the only way I could get this to come out quite the way I wanted to would be a significant process. That would involve rejoining all of the pieces, merging overlapping vertices, and then extruding the frame in a specific way. And even then would still be having difficulty to make it work quite the way I want it to work. Or I could extrude in faces one at a time. I suppose that would probably work. But I would still have to rejoin all of the pieces and then re-separate them to get it to do what I want it to do. So I'm just going to do it this way. It's a little imperfect. I'll exaggerate this one much more than I did in my previous one. So I'm going to pull it out huge. And hopefully that way it will show better in Godot. What I wanted to avoid was the angle on this face. I would rather if that angle was square, but procedurally, using the procedures that I'm using to make things work, that's actually more difficult than it seems. and unless I'm missing something very obvious. So what I want to do now is to change the origin of each of the pieces, and the reason for that is the way they're going to rotate in Godot. I don't think that this rotation is good. Whereas if I go object, set origin, origin to geometry, now the pieces rotate in a way that I think they should rotate. So I'll select them in the scene collection because it's the most organized way to do it and just makes things more simple, I think. Resetting the origin on each one, origin to geometry. Okay, so that's ready to export into Godot. I'll export that, Collada, just default settings. I'm going to put this into its own folder, but I'll give it the name crate because this is likely to become a replacement for my current crate. So just a replacement graphic with the new exaggerated details. So we'll get into Godot with that. That will be, see, inside of the folder demo, we'll have crate UV, the material. This is an experimental one, so we'll delete that. And the crate. So we'll come in to the import dialog. I want to import it as a rigid body, so we'll re-import that. Open it up and have a look at the difference. So that those exaggerations, I'm hoping, are going to show up a little better than on this one where I was more modest and didn't do things quite as exaggerated as I think that I should have. So to address the materials on this piece, I select all. We'll come into here, surface 1. In the roughness, I'm just going to undo the roughness setting that seems to happen by default. That's going to set it to 1, so it's maximum roughness, and get rid of that shininess that's very disruptive to the surfaces that light hits, and make it look more like a crate. We can get rid of the animation player. Now at this point, rather than trying to set up the whole crate because it's a little time consuming, we'll demonstrate with a couple of the pieces and see if we can make the process that I used in the other one a little more streamlined. So what we want to do is we want to add a child node. We'll add in a particles. Oh, it's right at the top. So we'll add in a particles, and why we're adding it to the mesh is that's going to locate it as a child of that mesh, so it's in the perfect location. On this, we want to select this mesh, and we want to save a copy of it. So we're going to save a copy of that mesh. We could call it crate mesh _1, and we'll save that into the demo folder. Then in particles, we're going to use that. So we'll go to drop passes. Here we'll load in that mesh. So that's in demo all by itself. We're going to make unique so it's distinct from the one it was saved off of. If we click on it, we can come into surface 1. We want to make this unique as well. And then set the parameter on it to be billboard mode, particle billboard. And that's going to give it the ability to be rotated. And we can see it's sticking out here. And it will act strangely, like it rotates strangely. But as long as the main one is staying where it's supposed to, things are working properly. Now, I think if we back out here, that we could quite possibly save this material now that it's been made unique. So we'll make unique again just to ensure that gets done. Yeah. So what we'll get here is, we'll call it emitter. I'm not sure about the spelling there, but we'll just ignore my bad spelling. So we'll call it emitter material. And then hopefully we can load that back in. So we'll back out of the materials and we'll start setting up the particles. So we're going to go emitting off. We only want to emit one particle. In time, lifetime, I set to 2, so it's going to exist for 2 seconds. It's a one shot. In process material, we'll get a new particles material, click on it. Direction, we want to set to up, so Y should be 1 for up. Initial velocity, I gave an initial velocity of 10, but that can be experimented with. I gave an angular velocity of 100, that can be experimented with. Well, anything can be experimented with. And I gave a velocity random of 0.5. So that's all of the emitter settings that I set for my demonstration for my first crate. So once we set those, we can come in and copy parameters. So we'll copy those parameters. We'll come into cube 2. We'll add a particle system to it. It ends up in the right location. Now we have this particles created. Let's go paste parameters. So we paste the parameters in there. We'll need to load in a second mesh. So we have to save cube mesh. That's up here. We'll save that. We'll just click on the first one and edit the number. So it's crate mesh 2. We'll save that. In our particles, we can load that mesh now. I believe we'll still have to make it unique. So we'll go make unique. And if we click on it inside a surface 1, we should be able to drag and drop our emitter material. And I don't know that that needs to be made unique still, but it should have all of the settings that are needed. So let's just click on it and check the parameters. The parameters are in billboard mode. So that looks like it should be working. And we'll go into particles and just review the settings. Emitting is off, amount 1, time. So all of our settings look to be correct. We have 10, 100, random, all of the settings look to be correct. So we would do that with each of the cube meshes. Then what I did, once I had all of the emitters in their proper location, by creating them as children of their meshes, was to make a spatial. I just named it explode. Took the particle emitters, using using the control key, so we can just select those and drag and drop them into particles into the explode. And I don't know why both of them didn't pick up, but I'm just going to undo that because I want to come back and finish this cube. Now we'll go back to my other cube to look at its setup. So once I'd put all of the emitters into their own spatial, and it's just a place to organize. I created a second spatial to put all of the meshes into, and what that does is gives me the easy ability to toggle their visibility rather than having to do them all individually. I gave it a timer. The timer is set as a one-shot timer. I used 2 seconds because that's the lifetime of the particles. So any more than 2 seconds, the particles have disappeared and everything's done happening. Then I gave it a timeout. For the shell, I changed the shell in a fashion so that it doesn't just bounce off of things now. I actually simply disabled its collision shape. I've left it a rigid body, and the idea of it bouncing off of certain things, that's likely to happen. I just didn't organize things yet. I added in an area and a collision shape, and the area has the on body entered. To make that work for a destructible, the crate is put into a group called breakable. So in script on the shell, when it enters a body, if the body is in the group breakable, it will make the function call to start in the breakable. So inside of the crate, function start is what turns on the emitters and makes the visible pieces not visible anymore. So basically, emitters will fill with the children of the explode spatial, which is all of the particle systems. That will be an array. The collision shape is disabled. It'll iterate through the emitters array, turning each of the particle systems to emitting equals true. So they'll emit their one particle and do the thing that they're supposed to do. Turns the pieces, toggles the visibility off, starts the timer. The timer runs its 2 seconds, which is the amount of time it takes for the emitters to do their thing. And when it times out, it just queue free. So that's how I got my first Destructible working. It is a little bit of setup, but I think that with this revamped crate with the slightly better graphic, the slightly exaggerated graphic, I think that it comes across pretty nicely, and it gets to avoid some of the issues that sometimes we have with these graphics, where particularly where they're too thin. So in the next video, I'll be looking at doing something like getting the new crate that I made to have maybe a fireball to go along with the explosion, so it would have a flash and then fly apart kind of deal. So that's a possibility for a future video. I hope this one was useful. This is just Godot protesting because I still have the import file open and unsaved. So it doesn't like when you start a scene when you have something like this still open, which is the DAE file. So the Collada export. Anyways, I hope this was helpful, and until the next video, take care.